efficiently. Okay, so today we're going to talk a little bit more about the databases. So we've been spending a lot of time interacting with the database via SQL Zoo, SQL Bolt, any other SQL things you've been playing with. But we haven't actually started creating our own databases and tables yet. So that's what today will be. So to start things off, I also just want us to understand the pattern of how things are connecting. So we've got our client side. Right? The client makes what to the back to a server? Makes a request, right? Request to a server. Server makes what to the client? Response, right? So you've probably seen this drawing before. So where does the database play into all of this? So we're going to have a database, we'll say over here. And the database is what's going to be storing all of our information. And our client will send a specific request to our server, and then our server will be like, oh, so you want all the people, let's say, right? So then the server is going to go communicate to the database. We're going to be using something called pgpromise to help us. Although different apps can use different things, right? It's just this idea of interaction. If we were using Rails, then it would be Active Record. But we're going to be using pgpromise. And then the database is going to send back some information in the form of JSON here. Is how we're going to want the information. And then the server will go ahead and pass that up as the response. Okay, so that's going to be the overall connection. That's going to tie our whole app. Any questions on that drawing? Yeah, Tim.
So pgpromise turns it into a JSON?
Yeah, pgpromise is going to turn it into JSON. What?
Does the server hold the database or the actual
They could be hosted in different spots.
different spots?
They just have to be able to communicate. Good question. Any other thing else? I thought I saw another hand, but maybe it flew down. Okay. Great. So so part of what makes a good database is planning ahead. Okay? That's don't underestimate the power of planning with building any of your applications. You should plan everything out. For one of the new words that we should learn today is a schema. So I'm going to write schema. I'm going to call it just .sql for now, but a schema is really just a visual representation of what your tables are. So that's what the definition of a schema is. Schema is representation of the database and table connections. Okay, so that's a schema. And so let's pretend we were planning out some kind of employees table or something. Right? So I'm going to pretend I made an employees table. Jesus Christ. Okay, an employees table. What would we want to have on it? Okay, so we would have an ID. So I would say that's probably some kind of primary key. What else would we want on our first day? Yeah.
ID role.
Role? Yeah, sure. Or a job or title, let's say. So unlike when we've been writing things before, we have to declare the types of what we want stored in the table. So we can't just like say, well, whatever, right? In JavaScript, we can. We can say like this. We could call this variable string, and it can point to an array, or it could point to a number. Even though it'd be really poorly named variable, you could do that, right? Other languages are type safe, and SQL is one of those that it cares about the type. You have to tell the database ahead of time. So a title, a job title, what would be a type for that? Yeah, Karen. Some kind of text. Sure. So I'm going to say text. What else might we want to know about an employee? Henry?
Years employed.
Okay, sure. Years. It might make more sense to do a start date because years employed would have to keep getting changed every day. We'd have to check it. While start date, we might be able to go and grab like how many people have been employed for this long, or we could see how many years they've all been employed by doing some math. So that's those type of things are things to think about, right? Do I want years employed? Something that's going to be changing, and I don't know when it should change. What's the type of that? Yeah, I think there's probably some kind of date in there. Will, what do you got?
Full-time, part-time.
Okay, maybe like a schedule. I'm going to leave that out for now. I want to keep it simple, but yeah. Karen? Names, right? Yeah, right? We definitely want our people's names. What data type would a name be? Text, great. Let's do one more. What's one more like, well, two more things. What's two more things that are important when you're talking about working? Salary, yeah, I'd say salary is important. How should we store salary? What? A number? Okay, maybe like an integer or something.
Wait, I have a question. What's
Yep.
the difference between, because when I was going to SQL, I saw that the data value, there's one that's integer and then one that's real.
That's what?
Real, for real.
Real?
It's like, it put like a decimal value in there.
Oh, that's like a float type. Yeah. Yes, maybe. Are you saying float? I don't know Rio. I know float.
I don't know.
Okay, yeah. You can definitely look up the specific differences. There's a lot of data types. Here, I'll show you some of them. We can go to the documentation. Okay. All right, this is the documentation. And we can see some of the data types here. So big int, a single 8-byte integer, big serial, auto-incrementing 8-byte integer, a bit number, or we can make a length fixed bit string, right? So there's like lots and lots of them. Date, this is for calendar year. And different data types of databases, like this is all going to be, this is a Postgres database is what we'll be dealing with. They all can like handle date. Some of them will handle date a little differently and whatnot. Some will have like a timestamp property. Let's see, real. Single precision floating point number. Floating things are usually just decimal numbers, so it probably would be expecting a decimal. But yeah, how would you handle salary? I don't know. It's up to you. What's one more thing that people generally like to know when they're working? Schedule for sure. That's something Will said. I agree. I just don't want to have to organize that. Yeah. What's one more thing? Who do you work for? Like your manager? What? Supervisor, right? So, this is maybe something we haven't thought about before, but manager ID. And so what what would this number be? Well, okay, so I would say that this is going to be some kind of foreign key, right? Because this, I'm going to point this to which table? Karen? So I'm actually going to make the argument that we can point this to our employees table because everybody's employed by the company. And so my employee and my manager should still also be in there. So this is a good example of when you would want to use a self join, which is something we haven't probably talked about yet, but I just wanted to plant a small seed. Oh, like maybe later or tomorrow or something. At some point we'll do it. Okay. This kind of makes sense. So let's do another one. Let's split up into groups of 4 or 5. I think you guys can do that on your own. And I want you to design Yelp. Design Yelp. Think about which. Yeah, she's like, didn't you do Yelp? Yeah, that's what I'm choosing. Think about which tables you'd want or need and how you'd connect them. Okay, so we'll split up into groups and then maybe we can share some of our different designs. Okay, let's spend like 20 minutes on this.